Ladies and gentlemen, we are looking at base angle theorem 4.7. It's going to deal with isosceles and equilateral triangles is how we're going to prove it. And it's a base angles of an isosceles triangle. You have two congruent sides. We talked about this the other day before your quiz. We've got a triangle. If the sides are congruent, then that means the base angles are congruent. Okay? So that's all base angle theorem is saying. If the two sides are congruent, the two angles have to be congruent. Okay? Base angle converse is the opposite. If the angles are congruent, that means the sides are congruent. Okay? If triangle is an equilateral, it's equiangular. And if a triangle is equiangular, it's equilateral. We talked a little bit about this when we went over equilateral isosceles and scaling triangles. Okay? All right, we've got two proofs here. I'm a little worried about you guys in proofs. So let's try doing this a little more together. The problem with this is we're proving a theorem. And remember, when we're proving a theorem, you can do things like draw, right? Going back to ancient Greece again. Remember, they had a lot of time on their hands. There's no TV, no music. They did a lot of math for fun. I know it's strange to you right now because there's so much more entertainment. But there are still people out there who do math for fun. Okay? And so they did things like measured it and drew stuff. So let's go over this. This is going to be a little more difficult of a proof than you're used to. But that's why I'm walking you through it, and I'm not giving you one like this on your test or quiz. Okay? I'm trying to give you proofs that are harder for you in class so we can have easier ones on tests and quizzes. Okay. First thing we always write down is the what? Given. So we've got the triangle ABC. And we know that AB is congruent to, AC. And we've got this down as the given. So we've talked about this before. Everybody's writing down the given, but what are you guys not doing? You're not marking the picture. So let's look at the picture. We have the triangle. We can't mark anything for the triangle ABC. What can I say for AB and AC? How do I mark it on there? Put a little line. We got AC and AB. That means they're equal to each other. Okay, we know what we want to prove. We want to get to the bottom that angle B and angle C are congruent to each other. Yes, Quinn? We're proving the base angle theorem. So it's like when you're defining something, you can't use the word. That's a really good question, though. You can't use that word in the definition. So we can't use the base angle theorem in it. So we've got to use all of our other stuff to get to it. Once we've proven it, we can use base angle theorem all we want. But it's like the ancient Greeks. They had to prove each of these theorems to work in order to use them somewhere else. Okay. So we've been doing a bunch of stuff where we prove two angles are congruent. How am I going to make this one angle into two angles? What could I do? Now remember, you can do things like draw. What's something you might want to do? Is there anything I can draw on here to make this two triangles? Just make a line. We're going to draw, and I heard somebody say bisect. We're going to make it so CAD is congruent to angle BAD. I'm going to just draw a little off. I'm going to draw a line just like that. And we're calling this drawing a line that bisects. Okay. So now we've got two triangles. I know I bisected it, so I know these two angles right here have to be congruent to each other. All right, so I have two triangles now. I've got two angles are congruent. I've got two sides are congruent. What else do I have up there that I can prove that this triangle, this half and half a triangle are congruent to each other? Well, let's label this first of all. What letter do you want to put here where this intersects CD? Okay. So we've got two halves of a triangle now. What do I see? What do I always tell you to look for? Reflexive. What could be reflexive up here? AD. Draw the bisect. The bisector. Yep. All right. Are these two triangles congruent now to each other?
Yes.
What by? So triangle ADC is congruent to triangle BAD by what? What is this? This is a side. This is a side, angle side. There you go. Okay. So, are angles B and C now congruent to each other? What would we use? What is something we learned recently that we could say the angles B and C are not congruent? Say it louder. CPCTC. Maybe I should give you guys a group quiz and I'll do it together because you did that with almost no help from me. It was awesome. We ready for the next one? How do we feel about this? Do you understand where it's coming from? Do you get that basically what we did is just made two triangles, set them equal to each other, found that base angles are congruent, and then since that worked, we're saying it always works. We've got that inductive reasoning. All right, let's do the back. It's the converse. And the converse means instead of proving the angles are congruent, we're proving the sides. So the first thing for any proof is we write down what? Given. Triangle ABC, and we've got angle B is congruent to angle C. So what am I going to do up here in my picture? Okay, so first I'm going to mark my given, and then yes, that is what I'm going to do. I'm going to mark that B and C are congruent to each other by given. Okay, and then Derek said, let's bisect it again to make two triangles. So I'm going to make, again, this down here, I'm going to make this D. I'm going to make it so that AD bisects it so that these two angles are congruent to each other. So I'm going to make angle CAD congruent to angle BAD by drawing a bisector. Do you know how the ancient Greeks drew the bisector? I mean, they literally pulled out a protractor, found out the angle, and divided it in half, and then made that line come right there. Okay? I'm serious. I'm not lying. Okay. So let's look at this. We've got two triangles now, right? This is split in half. We're going to use reflexive. We're going to say AD is congruent to AD by reflexive. Okay. Now what do I have to prove that these triangles are congruent to each other? Angle, angle side, perfect. Triangle ADC is congruent to triangle ADB by angle, angle side. Okay. Now, how am I going to get to AB is congruent to AC? CPCTC. Okay. Let's talk about this for a second because I'm about to pass out your quiz back to you. Let's talk about this. CPCTC. When can you use it? No. Only for triangles, but after what? You can only use it after you've already proven the triangles are congruent. Can you use it to prove triangles are congruent? No. So please stop writing that on your quiz. Okay? You have to prove triangles are congruent first. Then you can use CPCTC to prove that parts are congruent. Right? It says it right in the name. Corresponding parts of congruent triangles are congruent. Not triangles are congruent. The corresponding parts are congruent. Questions? Okay, I'm going to put up your writing. I'm going to ask people that have not taken their quiz to turn in their writing first. And then they can go. Once I have everybody's writing, we will go over the quiz.